Last year we studied about polynomials. We just recall. If p of x is a polynomial in x, that is x square plus 2x plus 5, that's a polynomial in x, then the highest power of x in p of x is called the degree of a polynomial. So for example, 4x plus 1 is a polynomial. Then what is the degree? It's the degree of 1 because x is power of 1. Same like 2x square plus 5x minus 7 is a polynomial of degree 2 because x to the power 2 is the highest power of x. That's so the polynomial of degree 2. Remember 1 by x minus 1 root x plus 5 or 1 by x square minus 5x plus 2 etc. in this form of equations. This form are not polynomial. Let's remember. Please remember that. So a polynomial of degree 1 is called a linear polynomial. And a polynomial of degree 2 is called a quadratic polynomial. Also a polynomial of degree 3 is called a cubic polynomial. For the general form of a quadratic polynomial. General form of a quadratic polynomial is a square plus bx plus c, where a, b, c are real numbers and a not equal to 0. This is very important. If a is equal to 0, this is not a quadratic polynomial. This is a linear polynomial. It's automatically changed to linear polynomial. So, general form of a cubic polynomial, that's equal to ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and a not equal to 0. Generally, we can tell that if p of x is a polynomial in x and if k is any real number, then value obtained by replacing x by k in p of x is the value of p of x at x is equal to k and is denoted by p of k. Okay. Then a simple question. Find the value of p of x is equal to x square minus 3x minus 4 at x is equal to minus 1 and x is equal to 4. So we want to find p of minus 1 and p of 4. So we have p of x is equal to x square minus 3x minus 4. So p of minus 1 is equal to, substituting the value of x by minus 1. That is minus 1 the whole square minus 3 into minus 1 minus 4. That's equal to 0. That is p of minus 1 is equal to 0. Then p of 4. P of 4 is equal to, substituting same method, 4 square minus 3 into 4 minus 4. That is equal to also 0. So here we get p of minus 1 is equal to 0 and p of 4 is equal to 0. So minus 1 and 4 are called zeros of the quadratic polynomial x square minus 3x minus 4. That is, we find p of minus 1, that's 0, p of 4, that's also 0, that is minus 1 and 4 are called zeros of the quadratic polynomial of x square minus 3x minus 4. So in general, we can conclude that a real number k is said to be a zero of a polynomial p of x if p of k is equal to 0. A real number k is said to be a zero of a polynomial p of x if p of k is equal to 0. We know that the zeros of a linear polynomial ax plus b is minus b by a. That we studied in the last year. That is minus constant term divided by coefficient of x. Now let us take a polynomial p of x is equal to 2x square minus 8x plus 6. We already studied in the class 9 factorizing the quadratic polynomial by splitting the middle term. Here we split the middle term minus 8x as the sum of two terms. So 2x square minus 8x plus 6 is equal to 2x minus 2 x minus 3. That is 2 into x minus 1 into x minus 3. So p of x is 0 when x minus 0 is x minus 1 is equal to 0 or x minus 3 is equal to 0. That is x is equal to 1 or x is equal to 3. Now let us find the sum of zeros. Here the sum of zeros is 1 plus 3, that is equal to 4. That we can express minus 8 divided by 2. Minus of minus 8 divided by 2. That is minus of the coefficient of x divided by the coefficient of x square. Also find the product of zeros. That is equal to 1 into 3. That is equal to 3. So we will write this as 6 by 2. That is equal to the constant term divided by the coefficient of x square. So in general, if alpha and beta are the zeros of a quadratic polynomial, alpha and beta are the zeros of a quadratic polynomial, p of x is equal to a square plus px plus c is equal, where a not equal to 0. Then we know that x minus alpha and x minus beta are the factors of p of x. This gives alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. That is sum of roots is equal to minus b by a, and the product of roots is equal to c by a. We already go through the sum of zeros and product of zeros of a quadratic polynomial. Now we will go through the cubic polynomial. So, cubic polynomial is degree of 3. Let p of x is equal to 2x cube minus 5x square minus 14x plus 8. So we will find p of 4, p of minus 2 and p of 1 by 2. Solving this, we will get the sum of zeros. Solving this, we will get 3 zeros. That means p of 4 is equal to 0, p of minus 2 is equal to 0 and p of 1 by 2 is also 0. Now we will find the sum of zeros. Sum of zeros is 4 plus minus 2 plus 1 by 2. that's equal to 5 by 2. So I will put minus 5 by 2. That's equal to minus coefficient of x square. Coefficient divided by coefficient of x cube. Now let us see the product of zeros. Product of zeros is 4 into minus 2 into 1 by 2. That's equal to minus 8 by 2. That's equal to minus constant term divided by coefficient of x cube. In cubic polynomial, there is one more relationship. This is equal to here alpha, beta and gamma, or A, B, C, D. Totally 4 variables are there. So we will have one more relationship in cubic polynomial. Consider the sum of products of zeros taken 2 at a chance. That's equal to 4 into minus 2 plus minus 2 into 1 by 2 plus 1 by 2 into 4. That's equal to minus 14 by 2. That is coefficient of x divided by coefficient of x cube. So in general, alpha, beta and gamma are zeros of a cubic polynomial. Ax cube plus bx square plus cx is equal to d, where a not equal to 0. Then alpha plus beta plus gamma, that is sum of zeros, is equal to minus b by a. Alpha beta plus beta gamma plus alpha gamma is equal to c by d, and alpha beta gamma is equal to minus d by a, that is product of zeros. That's all. Next class we will study